Dear students, welcome to Blackboard. Circles and its related terms. The collection of all the points in a plane which are at a fixed distance from a fixed point in a plane is called circle. The fixed point is called the center of the circle and the fixed distance is called the radius of the circle. So, collection of all the points from a fixed point at a fixed distance is called the circle. So this is the circle. This fixed point is called the center of the circle and this fixed distance is called the radius of the circle. A circle divides the plane on which it lies into three parts. Inside the circle, which is also called the interior of the circle. Second part is the circle itself, and the third one outside the circle, which is also called the exterior of the circle. So, circle is dividing the plane into three parts. First one is interior portion, second one is this boundary, that is circle itself, and third part is exterior. The circle and its interior make up the circular region. The circle, that means this boundary and this interior portion together known as circular region. If you take 2 points P and Q on a circle, then the line segment PQ is called a chord of the circle. Here you can see P and Q are 2 points on the circle, then this line segment PQ is called a chord of the circle. The chord which passes through the center of the circle is called the diameter of the circle. Chord which passes through the center, it is known as the diameter of the circle. Diameter is the longest chord and all diameters have the same length, which is equal to 2 times the radius. That is, diameter is equal to 2 into radius. A piece of circle between 2 points is called an arc. So, arc is a piece of circle between 2 points. So, this is an arc. The longer arc is called the major arc. Here you can see this is the longer arc and this is the shorter arc. Longer arc is called the major arc and shorter one is called the minor arc. The minor arc PQ is denoted like this. You can write PQ and draw an arc here, and the major arc PQ is denoted by PRQ. We are taking the one more point on that circle. When P and Q are ends of a diameter, then both arcs are equal and each is called a semicircle. Here also you can see 2 arcs, but both endpoints are the endpoints of the diameter. So each part of the arc are equal and each part is called the semicircle. The length of the complete circle is called circumference. If in a circle, this total length of the boundary is called circumference. The region between a chord and either of its arcs is called a segment of the circle. The region between a chord and arc, here you can see a chord and a arc. So this region is called a segment. There are 2 types of segment, which are minor segment and major segment. Here you can see 2 types of segment in a circle. The major part is the major segment and the smaller part is the minor segment. The region between an arc and the 2 radii joining the center to the endpoints of the circle is called a sector. Region between an arc and 2 radii. So this type of portion is known as sector. Minor arc corresponds to the minor sector and major arc corresponds to the major sector. So this small portion is the minor sector and this larger portion is the major sector. When 2 arcs are equal, that is each is a semicircle, then both the sectors and both segments become the same and each is known as semicircular region. That means if both the segments or sectors are equal, then each part is known as the semicircular region. Fill in the blanks. The center of a circle lies in the dash of the circle, exterior or interior. The answer is interior. A point whose distance from the center of a circle is greater than its radius lies in the dash of the circle. Its distance is greater than the radius, so it should be lies in the exterior of the circle. The longest chord of a circle is a dash of the circle. It is the diameter of the circle. An arc is a dash when its ends are the ends of a diameter. An arc is a semicircle when its ends are the ends of a diameter. Segment of a circle is the region between an arc and a dash of the circle. The answer is the chord. A circle divides the plane on which it lies in dash parts. A circle divides the plane into 3 parts. Write true or false, give reasons for your answers. Line segment joining the center to any point on the circle is a radius of the circle. We know it is true. A circle has only finite number of equal chords. It is false because we can draw infinitely many equal chords on a circle. If a circle is divided into 3 equal arcs, each is a major arc. You see here I have drawn a circle and there are 3 arcs. I marked arc 1, arc 2 and arc 3. If 3 arcs are equal, it is not major arcs. So it is false. Next, a chord of a circle which is twice as long as its radius is the diameter of the circle. We know it is true because diameter is 2 times its radius. Sector is a region between the chord and its corresponding arc. It is false because sector is the region between radii and arc. A circle is a plane figure. It is true. Angle subtended by a chord at a point. Theorem 10.1. Equal chords of a circle subtend equal angles at the center. Theorem 10.2. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Here you see I have drawn a circle and 2 chords AB and PQ. And here you can see angle AOB. This is the angle subtended by this chord AB at the center. Here also you can see angle POQ and this chord PQ. This angle POQ is the angle subtended by this chord PQ at the center. Then theorem 10.1 says that equal chords of a circle subtend equal angles at the center. That means if the chords are equal, then the angles subtended by that chords are also equal. That is, if the length of AB and PQ are equal, then we can say this angle AOB equal to angle POQ. Theorem 10.2 says that if the angles subtended by the chords of this circle at the center are equal, then the chords are equal. That means if angle AOB and angle POQ are equal, then we can say these chords AB and PQ are equal. Perpendicular from the center to a chord. Theorem: the perpendicular from the center of a circle to a chord bisects the chord. Next theorem: the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So here you see, here is drawn a circle with a center O. AB is a chord and OD is the perpendicular from the center to the chord. Then the first theorem says that the perpendicular from the center bisects the chord. Bisects means divide into two equal parts. So this OD divides the chord AB into two equal parts. The parts are AD and DB. So if OD is perpendicular to AB, then AD equal to DB. Second theorem, the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. That means if AD equal to DB, then this OD is the perpendicular from the center. Next, circle through 3 points. There is one and only one circle passing through 3 given non-collinear points. We know collinear points means points on the same line. Non-collinear points means points which are not lying on the same line. Here I have marked 3 points A, B and C. They are not lying on the same line. Then the theorem says that we can draw only one circle passing through these 3 points. There is one and only one circle passing through 3 given non-collinear points. Next remark, if ABC is a triangle, then there is a unique circle passing through 3 vertices A, B and C. This circle is called the circumcircle. Center and radius are respectively called the circumcenter and circumradius of the circle. That means a triangle ABC, then we can draw only one circle passing through the vertices A, B and C. Such a type of circle is known as the circumcircle. The circle which is drawn on the vertices of a triangle, that is known as circumcircle. The center of such a circle is known as circumcenter and the radius of such a circle is known as the circumradius. Equal chords and their distances from the center. The length of the perpendicular from a point to a line is the distance of the line from the point. Here you see the figure. There is a point P and a line AB. And I have drawn so many line segments from P to AB. The distance from P to AB is the perpendicular distance. Here PD is the perpendicular distance. This is the distance from P to the line AB. The perpendicular distance is the shortest distance. Theorem: equal chords of a circle are equidistant from the center. Next theorem: chords equidistant from the center of a circle are equal in length. You see, I have drawn here a circle and 2 chords AB and PQ. OM is the distance from the center to the chord AB. ON is the distance from the center to the chord PQ. Then first theorem states that if the chords are equal, then the distances are also equal. That is, if AB equal to PQ, then OM equal to ON. Second theorem states that if the distances are equal, then the chords are equal. That is, if OM equal to AN, then AB equal to PQ. Dear students, I hope you understood the topic in this video. If you have any doubt, please comment.